there, geometry students. This is Miss Hefty here, and we're still working in Chapter 5, and we're talking about triangles and triangle inequalities. And so today we're going to focus on the lengths of the sides of a triangle, and we're going to talk about the triangle inequality theorem. And so we need to be thinking about what kinds of measurements are going to make a triangle. And so I have 3 line segments that I have here, and you don't have them on your paper, which is fine. But I'm going to take these 3 pieces, and are they going to make a triangle or not? I move this one, there we go. Okay. Now those 2 pieces are not meeting. Now if I try and get them to meet here, they're not going to meet because these 2 pieces here and here are too short. And so the triangle inequality theorem tells us that the sum of the pairs of sides has to be greater than the third side. So if we take a look here, let's say that this side was 5 and this side is 2 and that side is 3. My 2 and 3 are not greater than 5, they're equal to. So if I continue to move those line segments, and I'm not sure I can get them exactly there, but if I continue to move them, do you see what's happening here? They're going to be on top of that line segment. 2 and 3 makes 5, so as I bring them together, they're going to land right on top of there. They aren't going to make a triangle. What I need is, I need it to be longer. I need this one to be longer. That's what I need. So then in that situation, this might be still 5, this still might be 3, but I made this one longer right here. So let's call that 4. So now when I bring them together, I can't get just the line segment here for anything, but if I were to bring them together, let me move this out of the way. If I bring this together now, they're going to meet, people. That's what they're going to do. So I need those 2 segments to be greater than the third segment. So let's draw a triangle here. I'm going to use that as green, this is red, and that is blue, and I'm going to call them P, Q, R. And so what I'm saying is I need to add the 2 sides together, which would be P, Q, which is my green, plus my Q, R, and it has to be greater than the third side, which is the blue one, P, R. And then I have to repeat that again. If that works, great. Then I have to go ahead and do my PQ plus, now I'm going to add it to PR, and that also is going to have to be greater than the QR. And so the 2 that I haven't added together yet is my PR plus my QR, and that has to be greater than my PQ. If I test all of those and they end up being, yeah, that's true, yeah, that's true, and yeah, that's true, then those segments will make a triangle. So let's take a look at our examples. Is it possible to form a triangle with the given side lengths and explain why or why not? So now you're going to have to show all of these details. You're going to have to communicate your mathematics in your homework and on your tests and quizzes. Just saying yes or no will not earn you credit. And so the triangle inequality theorem says add the 2 sides together and they have to be greater than the third side. So I need to take 3 plus 4 and it needs to be greater than 6. Is 3 plus 4 greater than 6? Yes. Then I need to add the next 2 together, 4 and 6, and it needs to be greater than 3. Is that true? 10 is greater than 3? Yes. So now I do my last one, which is 3 plus 6, and is it greater than 4? Yes. If I get all 3 yeses, then yes, these measurements will make a triangle. If I get a no, then it will not make a triangle. Let's take a look at our next example. All right, I'm using my triangle inequality theorem that says add the two sides together and they have to be greater than the third side. 6 and 9 has to be greater than 15. It cannot be equal. Remember on the previous page at the beginning of the lesson, I said that the sides were 2 and 3 and the longest one was 5, and it ended up lying right on top of it. It cannot be equal. Cannot be equal. So this one is a no. So this will not make a triangle. I don't need to go any farther. All right, let's take a look at our last one. I've got 8 and 1. Is that greater than 5? Yes. And I'm going to take my 1 and 5. Is that greater than 8? That's a no. 6 is not greater than 8. So then this will be no. These measurements will not make a triangle. All right, let's take a look at the next part of your lesson. And it looks like I have the same thing repeated twice. So I'm going to cross this out. Find the range for the measures of the third side of the triangle given the measures of two sides. So let's just take a look here a minute. I'm going to draw a triangle. I have no idea what it looks like. This is 1, this is going to be 6, and I don't know this side, so I'm going to call it X. I'm going to follow exactly the same process I did. I'm going to add two sides together, and they have to be greater than the third side. So I'm going to take 1 plus 6, and it has to be greater than the third side, which is X. So 7 has to be greater than X. That's my first one. My second one, I'm going to take my 1 and my X together, 1 plus X, and it has to be greater than 6. I'm going to move my 1 over, so X has to be greater than 5. Now I'm going to do my third one. I'm going to take my 6 and my X together, and that has to be greater than my third side, which is 1. Move my 6 over, X has to be greater than -5. Now think about this, people. This X is representing a side. So you cannot have a negative sides. So you're going to eliminate this one. Now I have these two. And I need to write that as one inequality is what I need to do at this point. I'm not going to do number 6 here. So if you need more room, go ahead and go into that area. My inequality at the end now is I need X. X has to be greater than 5. So X has to be greater than 5, and then it has to be less than 7. Less than 7. So I'm writing it as an inequality, compound inequality. All right, let's take a look at our last problem. Find the possible measures of X if each set of expressions represents measures of the sides of a triangle. So I've got the X minus 2, I've got 10, and I've got 12. And so I'm going to take a minute again. I'm going to draw a triangle. I have no idea what it looks like. I'm going to call this 12, I'll call this 10, and I'll call this X minus 2. I'm using my triangle inequality theorem again, and that says add the two sides together and they have to be greater than the third side. So I'm going to take my X minus 2, I'm going to add it to 10, and it has to be greater than 12. And I'm going to go ahead and simplify my inequality. So X minus 8, plus 8, excuse me, greater than 12. Move my 8, X is greater than 4. So I've done my first two sides. Now I'm going to move on to my second two sides. So I'm going to take my 10 and my 12, and they have to be greater than X minus 2. And you guys, you need to communicate all your mathematics. You need to write down all of this information when you're doing these on the quiz, test, and in your homework. So now I've got 22 has to be greater than X minus 2. And I move my 2, I get 24 greater than X. So X has to be less than 24. All right, I have one more to do here. I need to take my X minus 2, And I have not put it with 12 yet, and that has to be greater than 10. All right, so now let's take a look. That's x plus 10 greater than 10. So now I have x greater than 0. Now I need to take a look at my inequalities and see, first off, are they going to work on this side here? If I take numbers greater than 4, so let's say 5, and test 5. Is 5 going to make that be an integer side? Well, 5 minus 2 is 3, so this one works. This is okay. Now I'm going to move over to 24. Okay, I need numbers smaller than 24, so I'm 23. 23. If I put 23 in there, am I going to get an integer side, a non-negative, not an integer, but a whole number, not a negative number? That works. 23 minus 2 is 21, so this one is okay too. When I plug in 0, is 0 going to get me a non-negative side? No, 0 minus 2 is negative 2. So this one I am not going to use. So now I need to write my compound inequality. So I need numbers that are bigger than 4. So 4, x has to be greater, but it has to be less than 24. So there's my compound inequality to tell me what numbers I can use in those expressions. All right, well, you guys have a great night, and I'll see you in class tomorrow.